Hi, everyone, and welcome to Organic Chemistry on YouTube. Today, we'll be talking about stereochemistry, specifically about assigning the R and S nomenclature for assigning what's known as absolute stereochemistry. So the basics of this method involve first assigning this R or S label to an sp3 stereogenic carbon. A stereogenic carbon is interconvertible with an asymmetric carbon, a chiral center. All of these mean the same thing. So each of the groups that are attached to the chiral center will be assigned a priority, which is assigned mostly by the atomic number. There are some exceptions which involve double and triple bonds, which we can get to in a different episode. And finally, you'll be needing to remember your Newman projections because we'll use those to actually assign that R and S label. So here for this next part of the episode, let's go through a few examples that might be helpful. So in this first example, we recognize that this molecule has 4 different groups or 4 different atoms attached to the sp3 hybridized carbon. This doesn't mean that it's automatically chiral, but it's a good first step. The next thing to do is to assign a priority to each of these different elements. And we do that by assigning the highest atomic number, the highest priority, and down the line from there. So of these atoms that are attached to the carbon, bromine, fluorine, chlorine, and hydrogen, bromine has the highest atomic number, so it gets the top priority. The second highest is chlorine, the third highest is fluorine, and the fourth highest is hydrogen. The periodic table is really useful here if you're not sure about the different atomic numbers. The next step is to create a Newman projection where we make the lowest priority group, here are the cases, hydrogen, and the carbon to eclipse each other. When we do that, then the Newman projection looks like this. And then we simply take the different priorities, 1, 2, 3, and then we track the rotation to connect them. So here you go from 1 to 2 to 3. This is counterclockwise, which makes this an S configuration. And now let's do another example where the hydrogen is not already in the dash position. Okay, in this example, we again see 4 different groups attached to the carbon, making it a possibly stereogenic carbon. We then will assign the priorities. So bromine will get the highest priority again, has the highest atomic number, followed by fluorine, followed by carbon, followed by hydrogen. So now to put the hydrogen in the dash position, we need to rotate about the axis that I'm going to show in green. I'm going to rotate this 120 degrees to move hydrogen into the dash position. Okay, so if you notice, we've moved the bromine to where the hydrogen was, the hydrogen to where the fluorine was, and the fluorine to where the bromine was. And now we can create that Newman projection. And then we just track the relative priorities about this Newman projection. Here we're going clockwise, so this is the R configuration. Okay, and finally, let's talk about some questions that could be asked in office hour. 1, how are the double and triple bonds handled with the priority ranking system? This is a little complex and won't fit into a 5-minute YouTube video, but is a perfect question to ask in office hour. 2, what if there are 2 atoms that are the same? Is it still chiral? 3, how are the R and S labels applied to cyclic compounds? This is another example of a somewhat complex assignment process, but will be great for an office hour discussion. So with that, thanks very much. And that's been Organic Chemistry in 5 minutes or less.